In this video, I would like to explain how to use the Apriori algorithm to generate a frequent item set. Frequent item sets are used to generate the rules, association rules for data mining. Okay, so this is one of the two most important part of the association rules algorithm for data mining. Okay, let's look at the data. This data is from the table 6.1, page 250 of your data mining textbook by Han et al. Okay, here we have 9 data points or 9 transactions, like transaction 100, including 1 to 5, item 1 to 5, T200, including item 2 4, and so on. So you can think this one as more like a shopping basket for each customer. So customer 1, when he or she went to a Safeway, let's say she bought apple, banana, and cabbage. And then another customer, in his or her shopping basket, he or she has a banana and let's say ice cream. And the T300, another person's shopping basket, he or she could have a banana and a cherry, and so on. So from these transactions, we would like to generate the frequent item sets. So when we generate the frequent item sets, we should have a minimum support count. So in this case, in this exercise, let's use a minimum support item count is 2. So to be significant, it has to appear at least twice in transactions we are analyzing. All right, so now let's try to find a frequent item set with a varying the cardinality. So let's look at a one item set, meaning item set with only one item in it. Okay, so let's look at the data. So we have item 1, 2, 3, 4, and 5. Okay, so we have item sets, item sets in the, so far the candidate item sets with only one item in each item set. So I1, I2, I3, 4, and 5. And then we need to count how many times each item in each item set has occurred in our transactions. Okay, so let's look at the I1, item 1. So 1, 2, 3, 4, 5, 6. Okay, so support count is 6. So let's look at item 2. So 1, 2, 3, 4, 5, 6, 7. So support count for I2 is 7. Let's look at I4. So I4, okay, 1, 2, 2. So support count for I4 is 2. Okay, and how about I5? 1, 2. That's it. So 2. So support count for I5 is 2. Okay. And then we need to compare these support counts of each candidate item set with a minimum support count, which is set to 2. All right. So 6 is greater than 2, so we include that in our frequent item set. Okay. And 7 is greater than 2, 6 also greater than 2. And 2 is also greater than or equal to 2, and 2 is obviously greater than or equal to 2. So these all satisfy our minimum support count of 2. So these are our first set of item sets. Okay, so from these frequent item sets with the cardinality 1, we need to generate another set of frequent item sets with the cardinality 2, or 2 item sets. Okay, so to do that, we need to produce a all possible combinations of these item sets. Okay, so we have I1 and I2. Okay, I1 and I3, I1, I4, I1, I5. As you can see over here, I1, I2, I1, I3, and so on, I1, I5. Now look at I2. So I2, I3, I2, I4, I2, I5. Okay, and then I3, I4, I3, I5, and finally I4 and I5. Okay. All right. So now we need to count we need to count the frequency of these item sets. So let's look at 1, 2. Items 1, 2. So 1, 2. Okay. Transaction 100. So once and 1, 2. So twice. Okay, and 1, 2, so 3 times, and another 1, 2 in T900, so 4 times. So item set 1, 2 occurred 4 times. Okay, how about 1, 3? Okay, so here 1, 3, 1, 3, 1, 3, 1, 3, so 4 times. Okay. And how about 1, 4? Okay, 1, 4 in T400. I guess that's it. Okay, let's do it one more time. How about I5? I'm sorry, 1, 5. So 1, 5 in T100 and 1, 5 in T800. So it happened twice. So 2. So and so on. So you count these support counts for every item set, and then compare each count with our minimum support count of 2. So any item set below 2, we do not include in our the frequent item sets. So this is okay, this is okay, but I1, I4 is below 2, so we don't take it. Same thing with 3 and 4. 0 is less than 2, so we don't include that. I3, I5, 4 and 5, these are all below our minimum support count of 2. So we only include the item sets greater than or equal to 2 of the support count. So these are our level 2, frequent item sets. Okay. All right. From these item sets, now we need to generate item sets with the cardinality 3, or 3 item set. Okay. Before generating 3 item sets, let's make sure we understand this property known as a priori property. It says all non-empty subsets of a frequent item set must also be frequent. So when you have any item set, all these subsets of that item set also should be frequent. Okay. So let's use an example to explain the concept. Okay. So to generate a 3 item sets, we need to join all these item sets, 2 item sets. Okay. So let's look at the first one. I1, I2, I1, I3. So if you join them, we can have a 1, 2, 3 item set I1, I2, and I3. And if you look at I1, I2, I3, all the 2 item subsets are 1, 2, 1, 3, and 2, 3. Okay. And if you look at our level 2 item set, that includes 1, 2, 1, 3, 2, 3. So all the subsets of 1, 2, 3 are all frequent, as shown in level 2 item sets. So we include 1, 2, and 3. Okay. Now let's look at the next one. So we can join 1, 2 with a 1, 5. Okay. So if you join these 2 item sets, then we can have a 3 item set of a 1, 2, 5. Okay. So the subsets of 1 to 5 include 1, 2, 1, 5, and 2, 5. Okay. So if you look at our level 2 frequent item sets, we have 1, 2, and 1, 5, and 2, 5. Okay. So all subsets of 1 to 5 are members of L2 or frequent item sets. So we include a 1 to 5 as our candidate. Okay, so next one now is joining between 1, 3 and 1, 5. So if we join these two, and the 3 item set will be 1, 3, 5. Okay, so subsets of 1, 3, 5 include 1, 3, 1, 5, and 3, 5. So if you look at our level 2 frequent item sets, we have 1, 3, 1, 5, but we do not have item set of 3, 5. So the this one does not. So this item set 1, 3, 5 does not satisfy the a priori property. So we cannot include item set of 1, 3, 5 in our candidate. Okay, the next so we can join between 2 and 3 and 2 and 4, and then 3 item set will be 2, 3, 4. Item set 2, 3, 4, and we do the same thing. So item set 2, 3, 4, the subsets are 2, 3, 2, 4, and 3, 5. So if you compare these subsets with our level 2 frequent item sets, 3, 4 is not there. So this one does not satisfy the a priori concept. So we do not include a 2, 3, 4 in our candidates. Okay, and then also we can join 2, 3 with 2, 5. Okay, and then if we join 2, 3 with 2, 5, then it's going to be 2, 3, 5. And the subsets are 2, 3, 2, 5, and 3, 5. And the 3, 5 is not a member of L2. So again, this does not satisfy the a priori the property. So we do not include this in our candidate C3. So we do the same thing for 2, 4, 5. Okay. So once you generate a item set, now we need to count them. Okay. So if you count 1 to 3, okay, 1, 2, 3 over here, T800. Okay, and we have another 1, 2, 3, and 2 T900. So it happened occurred twice. Okay, how about 1 to 5? So 1 to 5 over here. Okay, so it happened once and twice, 2800. So it happened twice. So both satisfied our minimum support count of 2. Okay, so our level 3 frequent item sets include now 1 to 3 and 1 to 5. From these level 3 item sets, level 3 frequent item sets, we can generate a 4 item sets. Okay, so if we join these two, it will be 1, 2, 3, 5. Okay, and then we need to check all the subsets. But if you look at the data, there's only one transaction with a 4 item sets. Okay, 4 items. I mean, so that does not include a minimum support count of 2 anyway. So we don't even have to bother checking the subsets. Okay. Okay, so we're done. So the frequent item sets from these transactions are as follows. So from level 1, we had I1, I2, I3, 4, 5, and from level 2, we have 1, 2, I1, 3, 1, 5, and so on. And from 3 item sets, we have 1, 2, 3, and 1 to 5. Okay. So from these frequent item sets, the next step will be we will generate a association rules. Okay. All right.